Here, I'm going to demonstrate how to use the regression tool in Excel to run regression analysis. Okay, let's review our example first. In this example, the dependent variable is the prices of properties. The independent variable is square footage. First of all, let's look at scatters. Alright, let's see how we're gonna draw scatters over here. Select insert, and I am going to select and highlight both independent and dependent variables. I'm going to choose scatter. Here we go. Alright, from this scatter, it is pretty obvious this is not going to be a linear regression model. But we don't know exactly what kind of nonlinear model it is. So here I'm going to make two attempts. First one I'm going to try is third order polynomial model. Okay, let me delete the scatter, go back to our original data set. The model we are going to run first is this one. Y is our price, x1 is square footage, x2 in our case is going to be x1 square, x3 in our case is going to be x1 cubic. Alright, let's go back to our data set, and I'm going to create two columns first because we are going to create x1 square and x1 cubic. So this one let's call square footage square. The column, let's call it square footage cubic. Alright, to generate square foot square, all we need to do is, okay, B3 square. In D column, we want to have square footage cubic. And we're gonna create those x2s and x3s for all the other 10 observations as well. Alright, now we are ready to run regression analysis in Excel. Click Data, look for Data Analysis, click it, and go ahead and look for regression right here. Click OK. This is the regression window. First of all, we're going to need Y range, which is our dependent variable price. Let's highlight and select those. X range is nothing but our independent variables. In our case, they are x1, x2, and x3. It's just that in this example, x2 is x1 square and x3 is x1 cubic. Alright, we're gonna highlight and select all those three columns. And then we're gonna look for output range. Let's leave the regression output on the same page. Let's say in cell A15. Let's select it, click OK. Here we go. Now we got the regression output which I showed you in class. Okay, B0 is -105, B1 is 597, and so on and so forth. ESS is 70.298, R square is 0.992, adjusted R square is 0.9886. This is the first regression model I would like to show you. Next, I'm going to show you a different regression model because there are so many different nonlinear regression models. So more often than not, we're going to try quite a few of those and see which one gives us the best outcome. In our case, we're going to look for the best adjusted R-square. In the second model, what we're going to do is, okay, first of all, we're going to take square root of house price first. And then we are not going to include the cubic term or the third order polynomial, which we did in our first model. Instead, we are just going to include square footage and square of square footage in our second regression model. Okay, here's what we can do. Let's go back to our original data set, and let me copy those and paste it to a new page. Alright, because we do not need square footage cubic anymore, so let's delete it. In addition, we're going to need something called square root of price. So square root price. What we're going to do is, okay, we're going to take a square root of the house price. Okay, and we're going to do that for all the 11 prices. Here we go. Now in this model 2, we have a new dependent variable which is not the original price. Instead, it is the square root of the prices. Alright, now we are ready to run the regression analysis. Once again, go to data, look for data analysis, click it, and here we go. We got the regression. Select OK. This time, the Y input is going to be square root of price, which is our E column. So we can do that from E3 to E13. Our X range, okay, in our model 2, we're just going to include square footage and square footage square. So they're going to be our B column and C column. Select both, and as we did just now, we're going to leave the regression output in cell A15. Now click OK. Here we go. We get a new regression output. In this second model, what do we have? R square is 0.975 and adjusted R square is 0.969. Let's compare those two adjusted R squares. In model 1, adjusted R square is 0.988. So it looks like the first model is better than the second one. Of course, you can try many other different nonlinear regression models, as many as you want, and do the best to identify the best regression model you can find.